Hello and welcome back to another Marcus Maths YouTube video. Today we're going to be going over some AP Calculus BC. And first of all, before we get into that, I want to discuss the channel a little bit. Usually I've been doing SAT math content. Now we're going to mainly be switching towards AP Calculus BC review. I'm going to be doing a video a day all the way up to the exam in May. So I'll be going through the entire Khan Academy course of AP Calculus BC. And also on the weekends and close to SAT dates, I will also be doing some SAT review of the math sections, very similar to my 30 to 40 minute video long review of algebra, like the advanced algebra for SAT math, and I'll be going over those on the weekends and also very close to the SAT dates that College Board provides. That way, I can still be helping on a wide variety of maths. Of course, if you have any suggestions, please leave them in the comments. I will be very appreciative of any gestures. And that being said, let's get right into it. Make sure to like the video and subscribe if you're new to the channel. We're going to be posting a lot of this AP Calculus BC, a video a day to help with your study. So by the time it gets to AP exam day, you will be completely ready, completely refreshed with all of the materials. Now, if you don't know who I am, my high score is a 1570 on the SAT, super scored with 790 in the math section, 780 on the reading sections, and I've also scored a 5 on the AP Calculus AB exam. I'm taking AP Calculus BC this year. And if you're in AP Calculus AB, don't worry. AP Calculus BC has 2 more units, but apart from that, it's all the same material. Like today, we're going over Unit 1, Limits and Continuity, the first quiz. You'll see this material, it is the exact same in AP Calculus AB. Alright, so let's go ahead and get started with our first quiz. We have 6 questions. We're going to be looking over this limits unit. And let's take a look at our first question. We have the function g is defined over the real numbers. The table gives a few values of g. So we can see the x values are approaching 4 from the left side with these 3.9. Getting more 9s, increasingly getting closer to our value from the left. And we also have these values above our x value of 4, but more to the right. So we're approaching the x value of 4, both from the left and the right, and this is how a good table should show our function getting closer and closer to this limit. As we can see from the left, the function g of x, the y value is gradually approaching the y value of 12. And from the left, it is also gradually approaching 12. When both the left and the right-sided limits are approaching the same value of 12, that can be defined as the reasonable estimate or the limit of the function as x approaches the value of 4. So since both the left and right-sided limits are equal, the reasonable estimate for the limit of g of x as x approaches 4 is 12. Now, you'll see this in the video. If ever the left and right-sided limits are unequal, we can know for 100% certain that the limit does not exist. So that is when we would say DNE as the acronym, and we would select this answer choice on a multiple choice question. Okay, on to our next question here. We are going to be analyzing the function, the limit of h of x as x approaches -6. So let's go ahead and highlight our value. And we're going to be discussing is the table appropriate. Now, you saw in the last question, an appropriate table should have very close increments coming towards our value from the left, and also very close increments coming towards our value from the right. Now, in this case, these aren't exactly very close increments. If we look at our x values, it's all to a scale of 1. So we can't be determinative of our limit if the values are 1 unit away. We want to see in the previous question, they were 1,000th away in both directions. And that is appropriate for estimating limit. That is not the case for here. So we would say the table is not appropriate because the increments in the x values are constant. We want to increase by 1/10th, 1/100th, and then 1,000th in degrees of closeness from our value that the limit is approaching. If not, the table isn't going to be appropriate for accurately estimating a limit here. So answer choice C is the correct answer with this one. Now we're going from tables to a graph. We're looking for what is a reasonable estimate for the limit of h of x as x approaches -7. So we're going to focus in on our x value of -7, and we're going to look at the two-sided limits, just like we were doing on our tables, the left-sided limit and the right-sided limit. Let's take a look. Our left-sided limit approaching our x value of -7, it's this part of the graph right here. We can see we are approaching a y value of a little bit above 1. So let's just say it's equal to 1, but it's a little bit above, it's very close to the y value of 1. So we will notate this as the limit of h of x as x approaches -7 from the left with this negative exponent. From the right will be a positive exponent. This limit is roughly equal to, let's use the approximately, it's roughly equal to 1. Then if we look from the right, our second one-sided limit, we're going to be using this part of the graph. The closer and closer that that the x value gets to -7, we can see the y value is also approaching 1 from the right. So it will be the exact same limit expression, but now it will be from the right. When our one-sided limit expressions are equivalent to each other, that means that the limit does exist. And we would say the closest value to 1, that's a little bit above it, is indeed 1.3. So we would select answer choice C as the correct answer to this question. All right, another graph one. We have the limit of g of x as x approaches 5. And as we can see in the definition, we can see defined for all real numbers except for when x is equal to 5. We know it's very important to not get thrown off by this statement, because even if the function is not defined at a point, we can still find the limit of the function at that x value. So that is what makes these limits so valuable. On our previous question, you saw that we had a defined value for -7, but it was not even as part of the graph. And that is not the limit. That is just a defined point. So with these limits, we're only going to be looking at our one-sided limits, and we're seeing what value is the y approaching as x approaches 5. Once again, start with our left side. We can see that the y value is going to approach -2 as the x value approaches 5 from the left. And as we look to our right-sided limit, we are once again approaching -2 from x. We are once again approaching the y value of -2 as x approaches 5 from the right. And when our one-sided limits are equal to each other, we can find a definite answer or a reasonable estimate for what the limit is going to be. Okay, consider the graphs A, B, and C. Which graphs agree with this statement? The limit of h of x as x approaches 0 from the left is equal to 4. So we're going to analyze this one-sided limit on each of the answer choices. Let's start with answer choice A. Alright, so we're going to be taking a look at the value of 0 and the limit as x approaches 0 from the left. We can see with answer choice A, as x is approaching 0 from the left, the y value is actually approaching +1. +1 is not equal to +4, so answer choice A is not an answer that we're going to select here. Let's take a look at B. As h of x approaches 0 from the left, we're going to be looking at this side of the graph, and the y value does indeed approach +4. It doesn't matter what the right-sided limit is doing, we are only looking at the left-sided limit for this specific question. And then finally, answer choice C, once again, the left side of the graph, we're going to be approaching the x value of 0, and the y value does indeed approach +4. So the correct answers with this are both B and C. And finally, we have another table question. What is a reasonable estimate for the limit of f of x as x approaches -3 from the right? So once again, we are filling these good requirements. These increments are getting progressively smaller, and we are progressively approaching a y value. We can see from the right, we are only going to look at the right side of this table, and we can see the value is approaching roughly +1. Because these increments are so small, we can be more steadfast in our estimate. So the answer choice of +1 for this question is indeed going to be correct. As x approaches -3 from the right, we are getting increasingly approaching the y value of +1. So answer choice C is correct, and that is this first quiz. Calculus is going to start off easy, but we're just going to be building on these skills over time. We're going to be talking about more limits on the next video tomorrow, and I hope to see you then. And I hope you found this video helpful. If you have any questions, leave them in the comments, and I will see you tomorrow for our next video. Goodbye.